Hi, 6th grade. We're going to do lesson 6-5. Which is called mental math. 6-5, mental math. You guys should have learned all of these properties previously, but we definitely need to review them. You need to take this down in your notes. The commutative property. It says that changing the order of addends does not change the sum. So 21 plus 13 and 13 plus 21, it's the same thing. So the commutative property is basically telling you that you can move around addition problems. You can switch the order in an addition problem. It also says that changing the order of factors doesn't change the product. Factors are the numbers involved in a multiplication problem. So 5 times 7 and 7 times 5 would equal the same thing. So in addition and multiplication, the commutative property applies. You can multiply or add in whatever order seems best to you. Next, we have the associative property, which states that changing the grouping of addends does not change the sum. Okay, so we've got 3 plus 8 plus 4 and 3 plus 8 plus 4. But do you see how here we've got the 3 and the 8 grouped to do that first? And here we've got the 8 and the 4 grouped to do that first. And so it doesn't matter how you group them, the sum will be the same. And the reason that that's important is because sometimes your work is easier if you group things differently. The same property, the associative property, also works for multiplication. 2 times 7 times 4, 2 times 7 times 4. But here we're going to do the 7 times 4 first, and here we're going to do the 2 times 7 first. But either way, you will get the same answer. The distributive property is definitely the trickiest one. It says when you multiply a number by a sum, you can find the sum and then multiply, or you can multiply the number by each addend and then find the sum. So you have choices, and this one's pretty confusing. So if you have this problem to do, 3 times the quantity 8 plus 4, here they're saying you can do the 8 plus 4 first and get the 12, and do 3 times 12 equals 36. That certainly seems pretty simple in this case. Here we've got the same exact problem, and look at all the trouble they're going to solve this. But they are demonstrating use of the distributive property, which is an important property, even though it looks more complicated in this particular situation. They're saying you can distribute the 3 across the 8 plus 4. You can do 3 times 8, that's this right here. And then 3 times 4, that's this right here. And then add them. 3 times 8 is 24. 3 times 12 is 12. And 24 plus 12 is 36. So it's 2 different ways to do the same problem. This one involves using the distributive property more. It will be useful eventually, even if you don't see it now. Now you're going to be asked to tell which property is being used. In the commutative property, all we've got is either addition and addition, or multiplication and multiplication, with the numbers flip-flopped. Numbers flip-flopped. That one's commutative, okay? With the associative property, again, we've got just addition or just multiplication, and we've got some parentheses moving around. Okay, so that one is the associative property. In the distributive property, you got all kinds of things going on with parentheses and addition and multiplication. So hopefully that'll help you distinguish which property is being demonstrated. So let's just go ahead and look for the commutative property. The commutative property didn't have any parentheses in it, okay? So number 2, we're just changing the order of addends. That one is the commutative property. Number 4, no parentheses there. We're just changing the order of factors in a multiplication problem. Commutative property. All the other ones have got parentheses in them. Well, let's look for the associative property. The associative property is going to have the same numbers on both sides. It's going to be either all addition or all multiplication. We're just moving some parentheses around. How about this one? All multiplication, 326, 326, and we're just moving some parentheses around. So that one's the associative property. How about number 3? Is it the same problem on both sides, just moving some parentheses around? Nope. Is this the same problem on both sides, just moving some parentheses around? Nope. How about this one? Yep, same problem on both sides, moving some parentheses around, so the grouping is different. So that's associative. And you can guess that these other two right here, what's left? That's the distributive property. 4 times 8 plus, and 4 times 5 is the same thing as 4 times, add those up, 13. 3 times 8 plus 3 times 4 is the same thing as 3 times 8 plus 3 times 4. Okay, here they want you to identify the property shown and figure out what number goes in the place of the letter, okay? So here, can you see that it's 9 plus 16 equals 16 plus 9? All they did was move the numbers around with addition, and that's called the commutative property. In this one, you see it's got multiplication and addition. Okay, that one's going to be the distributive property. But what number goes here? 3 times this equals 3 times this. The A is going to have to be 15 because it's the same thing as that. Okay, here we've just got a bunch of multiplication and we have moved some parentheses around. That's grouping. That's associative property. 4 times 3 times 2 equals 4 times something times 2. And that something has to be a 3. Number 10. We've got addition and multiplication going on in there. That's going to be the distributive property. 6 times 9 plus 14 equals something times 23. Well, this is 23, goes there. So that 6 is going to have to go there. That's going to have to be a 6. Okay, now you're going to have to make some choices about what to do first. We're going to go ahead and follow our order of operations and do 4 times 5 is 20 plus 17 is 37. Nothing very interesting about that. Let's do number 4. Oh, look, we're just adding a bunch of numbers together. There's an order that you can do this in that would be simpler. So 12 plus 8. See, that's easy because that adds up to 20 plus 7 plus 13. I'm crossing them out to make sure we take care of all of them. 12 plus 8 is 20, plus 7 plus 13 is 20, and then add them together and you get 40. If you had just added them up, you'd have gone 12 plus 7 is 19, 19 plus 8 is 27, 27 plus 13 is 40, and some of you may not have been able to do all of that in your head. So look for things that add up to tens, like 12 and 8 add up to 10, and 7 and 13 add up to 10. All right, let's look at number 2. Here's where moving things around can be very useful to you. If you just did 25 times 3, 75 times 4, you're probably not going to know 75 times 4 off the top of your head, although some of you might. But we can do 25 times 4. times 3. 25 times 4 is 100, times 3 is 300. So do you see how if you look for this multiplication here makes 100, that's easy to multiply with. So be looking for things that make 10 or 100. They can make your work easier. On number 5, I just go ahead and do 3 times 2 is 6 because the order of operations tells us to do that. And 10 plus 6 is 16, not much to that one. Let's look at number 8. Again, we're looking for things that can multiply to make 10. So I do 2 times 5 times 6. 2 times 5 is 10. 10 times 6 is 60, so that's pretty simple. You could also have done 5 times 6 is 30, and 2 times 30 is 60. That would have been good as well. But probably if you'd have done 2 times 6 is 12, and then 12 times 5 is 60, you might not have known that 12 times 5 was 60. So make things that multiply to 10 or to multiples of 10. You will be required to show your work and show how you group things. All right, now here's how the distributive property is useful. When you have a 1-digit number times a 2-digit number, you can break that apart very easily. And here's what you do. 4 times 10 plus 4 times 6. Now, I do this in my head all the time. So I go 4 times 10 is 40, plus 4 times 6 is 24, and 40 plus 24 is 64. Now, that may look like more work than just writing out 16 times 4 to you, but perhaps you can get to the point where you can do that problem in your head. Let's look over here. Again, we have a 1-digit number times a 2-digit number. So we're going to do 8 times 30, because that's what that 3 represents, plus 8 times 1. 8 times 3 is 24, so 8 times 30 is 240, plus 8 is 248. Okay, so that's how we use the distributive property to solve a problem that's 1 digit times 2 digits. Okay, we need to do a little word problem work here. It says each ticket to a play costs $27. How much will it cost to buy 4 tickets? Which property did you use to solve this problem with mental math? I'm hoping that you will see that the problem is 27 times 4. And the only thing that we can do with that in terms of these properties would be the distributive property. So you're going to do 4 times the 20 plus 4 times the 7. 4 times 20 is 80, plus 4 times 7 is 28. And on your paper, you'll have more room under there, and that would add up to 108, which we would label. That looks like that'd be $108. Distributive property. You need to say that also, don't you? Number 23. Mr. Stanley bought 2 cases of pencils. Each case has 20 boxes, and in each box there are 10 pencils. Use mental math to find how many pencils Mr. Stanley bought. Now, I think you're probably going to have to read that question more than one time. So I think you can imagine that there are 10 pencils in one box. So a box of pencils with 10 pencils in it. And then you take 20 of those boxes and put them in a giant case. Okay, so that makes a case. And this person bought 2 cases of pencils. So to me that looks like 2 cases which each contain 20 boxes, and each box contains 10 pencils. So this is 2 multiplication problems basically, and you can do them in any order you want. Honestly, I don't think the order matters a whole lot here. I think it's pretty easy any way you do it. So 2 times 20, and again, you've got room underneath there, would be 40. Bring down the times 10. 4 times 1 is 4, and you got to bring down both of those zeros, which would be 400. And we need to label that pencils. And the property used there, well, we didn't really move anything around, but we could have used associative, I suppose. You could also have used commutative. Doesn't really matter on that one.